Hello viewers, in today's class we are going to discuss one important definite integral in which we'll use some important properties of definite integrals, right? So let us start and let us evaluate this integral in which we have to find the integral from 0 to 2 pi sine raised to 10x cos raised to 9x dx, right? So let us call this integral as I, right? So now to evaluate this integral, what we will do, let us take this integrand as f of x, right? So we have f of x as sine raised to 10x, and here we have cos raised to 9x, right? So what we will do, we'll try to apply some important properties of definite integrals to find the value of I, right? Okay, now see, here we have the limits from 0 to 2 pi, right? And let us consider an important property of definite integrals, that is 0 to 2a f of x dx, right? So whenever we have an integral of this type, that is 0 to 2a fx dx, then the value of this integral is 2 times the value of the integral from 0 to a f of x dx, right? And the condition is that f of 2a minus x should be equal to f of x, right? So this is an important property of definite integrals, which can be utilized to evaluate these kind of integrals. So now if we compare this integral with this one, then we can see that here we have the lower limit as 0, right? And the upper limit is 2 pi, right? And here we have 2a. So if we compare 2 pi with 2a, then the value of a is pi, right? Okay, so now to apply this property to this integral, we have to see whether this condition is satisfied or not. That is, f of 2a minus x is equal to f of x or not, right? So let us first find f of 2a minus x, right? So f of 2a minus x implies f of 2 pi minus x, because a is our pi, right? So now to find the value of f of 2 pi minus x, what we will do, we'll replace this x by 2 pi minus x in this expression. So we have sine raised to 10, and here we have 2 pi minus x, and then we have cos raised to 9, and here we have 2 pi minus x, right? Now here comes an important application of trigonometry, right? Now see, from trigonometry we know that sine of 2 pi minus theta is equal to minus sine theta, right? And cos of 2 pi minus theta is equal to positive cos theta. So what we will get here, we have sine raised to 10 2 pi minus x. So sine 2 pi minus x is equal to minus sine of x, and here we have the power 10, and here cos 2 pi minus x is positive cos x, and here we have the power 9, right? So now here we can easily see that minus 1 raised to 10 is positive 1. So we are left with simply sine raised to 10 x, and here we have cos raised to 9 x, right? And we can see that this is f of x, right? So we have seen that this condition is satisfied by this function f of x, right, when a is equal to pi. So now f of 2 pi minus x is equal to f of x. So we can apply this property to this integral. So now this integral I can be written as 2 times, here we have 2, then integral from 0 to pi, because a is pi, right? And f of x dx, f of x is the sine raised to 10 x, and here we have cos raised to 9x dx, right? So now this integral reduces to this integral. So now viewers, here we'll apply one more important property of definite integral to simplify this integral, right? So let us take one more important property, and the property is 0 to a f of x dx is equal to 0 to a f of a minus x dx, right? So this is an important property of definite integrals, right? So 0 to a f of x is dx is equal to 0 to a f of a minus x dx. So x is replaced by a minus x, right? So we'll apply this property to this integral, right? So let us call this integral as integral 1, right? So now let us replace x by pi minus x in this integral, right? Because we are now applying this property to this integral. So we have I, and here we have 2 times 0 to pi, and we have sine raised to 10, and now x is replaced by pi minus x, and here we have cos raised to 9, and here we have pi minus x dx, right? Now again, here comes the role of trigonometry, right? Now see, from trigonometry we know that sine of pi minus theta is equal to sine theta, and cos of pi minus theta is equal to minus cos theta, right? So what we will do here, we'll replace this sine pi minus x by positive sine x, because sine pi minus x is sine x, and here we'll raise this term to the power 10, and here we have cos minus cos x and raised to 9 dx. So now we can see that here we have minus 1 raised to 9, and this is an odd power because this is minus cos x raised to 9. So minus 1 raised to 9 is minus 1. So we have I, and we have minus 2, 0 to pi, we have sine raised to 10 x, and then we have cos raised to 9 x dx, right? So minus 1 raised to 9 is minus 1, and we'll keep this negative sign outside the integral, right? So this is integral number 2, right? Now we can see that this portion, that is 2 times integral from 0 to pi sine raised to 10x cos raised to 9x dx is our I, right? So I is now equal to minus I. So we have I plus I, taking minus I to the left hand side. We have 2I is equal to 0. So I is equal to 0, right? So this is how we can solve these type of integrals by making use of these properties, right? So the value of this integral is equal to 0.